Thank you, Chairman, Professor Ayin Rak.
Yes, in the middle you have the laser pointer.
Okay.
Zero for changing.
Okay. Good afternoon, ladies and gentlemen. My talk today will be a review on crack initiation modes of metallic materials in very high cycle fatigue. Okay. At first, let me explain the main target of this work. As you know, in the very high cycle regime, we can often find a characteristic SN property consisting of the first SN curve in the conventional life region, less than the 10 to the 7 cycles, and the second SN curve in very high cycle region, such as gigacycle regime. Thus, we have duplex SN characteristics as reported by many researchers. Okay. Such a duplex SN property has been interpreted as the superimposition of the SN curve for the surface inserted fracture in usual life region, and another SN curve for the interior inserted fracture in very high cycle region, right? Okay. But sometimes we have observed the various different types of fracture in both of the first and second SN curves. What is the general aspect of the fracture modes of the structural metallic materials in such a wide life region, including short life and very long life? This is the main aim of the present study. Let me show you the typical example of duplex SN characteristics. The fatigue test data for the bearing steel in rotating bending obtained by the authors are depicted in this SN diagram. SN diagram, where the experimental results obtained by Goto et al. For same steel are also plotted by using the different marks. So we can find the clear duplex SN characteristics consisting of the respective SN curves in the usual life region and the very high cycle region. Here you can find several data points for surface inserted fracture, even in the very high cycle regime. Thus, the surface inserted fracture can take place in the very high cycle region, although the predominant fracture mode is interior inserted fracture. Paying a particular attention to this point, fracture modes reported along the respective SN curves are newly reviewed by making reference to a series of the authors' research together with several historical papers reported by other researchers. Here, let me show you several examples of the fracture surface along the first SN curve, short region. This one indicates the fracture surface of the bearing steel failed in rotating bending at a very high cycle, very high stress level, having the very short life. Of course, fatigue crack took place here on the specimen surface. This one indicates the fracture surface failed in axial loading. Okay. In this case, the fatigue crack took place here. The right-hand side indicates another example of the fracture surface of the spring steel, very high strength steel in rotating bending. In this case, you can find very sharp and very fine surface flow introduced in the process of machining, surface finishing. Let me show you the traditional aspects of surface-initiated fracture in the usual life region less than the 10 to the 7 cycles. This one indicates the slip band crack observed on the surface grain of the low carbon steel in rotating bending. Okay. You can find very clear slip band crack penetrated in the entire grain size. And this one indicates another example of the specimen surface observed by using the optical microscope. You can find several aggressive slip band on the specimen grains, and in this case, this slip band crack becomes a predominant crack, leading the specimen to the final fracture. And right-hand side indicates the illustration of the fatigue crack initiation mechanism proposed by Wood and Forsyth, and very famous. So this model have been reconfirmed by many researchers. This slide indicates the formation of grain boundary crack for low carbon steel. This one indicates the specimen surface observed before the cyclic loading, original surface. Please look at these 3 grains, A, B, and C. And this is the micrograph observed after 10 to the 5th cycle of the same area. The A, B, C is corresponding to A, B, C. So we can find aggressive slip band on these 3 grains. However, if we remove a very thin surface layer by the electroporation, we can find this image. Okay? So we can find fatigue crack as shown here. So this crack appearing along the grain boundary. This is one of the crack initiation mode. This slide indicates some other type of crack initiation. Left-hand side indicates the surface inclusion initiated fracture. Okay? The right-hand side indicates the several cracks formed on the specimen surface, and we can carved fine cracks, several carved fine cracks along the prior alternative grain boundary, and sometimes we can observe straight fine crack along the packet boundary. Packet means the some grain inside of one grain. Okay. In this place, let me show you some examples of the fracture surfaces along the second descent curve in the very high cycle regime. Okay. So this is the fracture surface failed in the rotating bending, and you can observe the very clear fissure here, and we can find inclusion at the core portion of the fissure. Right-hand side indicates the fracture surface failed in the axial loading. In this case, the crack initiation site is very deep from the specific surface. Okay. The difference of the of this aspect is attributed to the fact that stress distribution is quite different from each other. In axial loading is uniform distribution, the rotating bending is very steep slope. Okay. And this one is the similar type of crack initiation type. And at the center of the fissure, we can observe the inclusion over here, and we can find the fine granular area in the vicinity around the inclusion, as shown here. However, in this case, we can observe very clear inclusion here at the core portion of the fissure. However, we cannot observe any FGA, fine granular area, in this case. What is the difference? If the delta K value at the edge of the inclusion is less than the delta K threshold, the FGA can be formed, as shown here. However, if that value is larger than the delta K threshold, such a FGA cannot be formed. And we have some other types of crack initiation mode. This one is a fine granular area at the crack initiation site. However, we cannot observe any inclusion inside this fine granular area, only fine granular area. Okay? So maybe weak microstructure is the key parameter to cause this kind of crack initiation. And the right-hand side indicates the surface inclusion induced fracture in the second SN curve in the very long life region. And this is the similar results for magnesium alloy and bulk amorphous alloy. This is the example of the fracture surface in the very long life region. The crack took place here from a pinpoint. However, in the short life region, definite length crack insertion site is not the pinpoint. Okay. And maybe you know, this is the Mufurari model on sweep band crack formed in the very high cycle regime. Predominant crack takes place in the surface grade during the long sequence of cyclic loading. Let me skip this one. Here, let me make overview of the entire fracture modes in very wide life region. Very wide life region means including both life region. You can find very clear duplex SN curves, and predominant sweep bands is the most predominant. I'm sorry. Persistent sweep bands is the most predominant fracture mode in the first SN curve. However, there can be some other type of crack initiation, as I explained just before. And this is the second SN curve. The interior inclusion induced fracture, which is the most predominant fracture mode in this second SN curve. Okay? However, even in such a very long life region, we can have a lot of different type of crack initiation modes. This is the concluding remarks. let me skip to read due to the limit of the time maybe.
Well, you can finish here.
Okay. Okay. Let me read only one important point. Okay. Number 2. As the predominant fracture modes are on the second SN curve, radon-like region, we have the interior inclusion-initiated fracture. This is true. However, micropore and weak microstructure surface some other kinds of crack initiation mode we can have. This is the most important point. In some cases, researchers in this area usually say the first SN curve is appear along the surface initiated fracture. However, the second SN curve is fundamentally governed by the interior including initiated fracture. However, we can have various different types of fracture crack initiation mode we can have. This is the most important point. Thank you for your attention.